Hi everyone, in today's video we're going to be taking a look at an example of planes. So we're asked to show that every equation ax plus by plus cz plus d equals 0 with the square root of a squared plus b squared plus c squared not equal to 0 represents a plane in space. So pause the video, work out your own solution, and then on the next slides I'll work through my solution. So since the square root of a squared plus b squared plus c squared is not equal to 0, the numbers a, b, and c are not all 0. So therefore there exist numbers x naught, y naught, and z naught such that a x naught plus b y naught plus c z naught plus d equals 0. So then the equation ax plus by plus cz plus d equals 0 can be written as ax plus by plus cz plus d minus ax naught plus by naught plus cz naught plus d equals 0. And we can verify this equation works by looking at the terminal ends of both of these equations. So we got 0 and 0. 0 minus 0 equals 0. So this is a satisfactory equation. So before I go to the next slide, I want to sort of preface our next step by distributing this minus sign. So we're going to see that d minus d, so that's going to cancel. And then we're going to want to group by like terms, as you can see here. So we have a times x minus x naught plus b times y minus y naught plus c times z minus z naught equals 0. So then this equation should look kind of familiar, as it's the equation of a plane through a point x naught, y naught, and z naught. So since this equation represents a plane, then the initial equation, this one, which we're asked to find, which we're asked to show represents a plane in space, does actually represent a plane in space. Again, sort of in dealing with the sort of properties of planes, we have our normal vector here as IA or AI plus BJ plus CK. And finally, our initial assumption that the square root of a squared plus b squared plus c squared is not equal to 0 guarantees that the normal vector is not equal to the 0 vector, which is, again, something we need because if our normal vector was 0, we just wouldn't have a plane, because our normal vector, again, is the vector that is normal to our plane. And if that vector is 0, then we don't have a plane.